Welcome to massive open online course on chemical process intensification. So, under the module 3 role of process intensification in sustainable development, in this lecture we will discuss something about strategies in process design. Many options have been proposed to reduce the environmental impact of human activities. So, this is one of the component for the process intensification in sustainable development, and the use of renewable energy sources is an option which must be explained in the next decades in order to reduce the emissions of the greenhouse gases by industry into the atmosphere. As an example, we can say that whenever we are producing biofuels from the biomass, so in that case it is considered that one of the most promising alternatives in the transportation sector where biofuels are being used in green technology, and this is the process what we can say it is a process intensification in chemical engineering process. So, production of biofuels are nowadays considered as a process intensification where the less emission of the carbon can be produced by this biofuels production. Now, to explore, it is required to develop and design a sustainable process by which you can produce these biofuels from the natural sources. So, that is why you need to have the strategy to actually design the process for the less emission of the greenhouse gases, even some other products whatever produced by the process for our daily life products. In that case, you have to intensify the process in such a way that process design should be in that direction where you are getting the less polluted environment. Now, why need of that process intensification in that particular process design? So, in the area of process engineering, you know that it is of particular interest to design the process with low energy requirements and the use of minimal number of equipment, because in that case you will actually consume less energy if you are producing different products by that integration of the process or intensify the process in other way and design it in such a way that you are consuming less energy. So, by use of minimal number of that energy and equipment, you can intensify the process. That is why any process in chemical engineering needs some process intensification strategy, and in that case to develop the production process in plants as well as the possible and with low total energy requirements, you need to make a policy in such a way that your process requirement should be less energy and the equipment will be less in that case. So, there are several aspects of that intensification, maybe in terms of size, in terms of energy, in terms of environmental impact, you can design the process. So, you can reduce the size of the plants, the scope is reducing the size of equipments or the number of operations in the process, or using multiplication or multifunctional equipment where you can that intensify the process to get the output by consuming less energy and the number of equipments in the particular process. So, if you integrate the process, you can reduce the size of the equipments as well as that number of equipments there. To reduce the energy requirements, also the proper use of energetic sources inside the process is mandatory also. What type of energy you are actually going to use, that also to be considered, whether it is biofuels or some other energy that you are consuming, whether it is that greenery way or not, that should be considered for the design also. By reducing energy requirements, the direct reduction on environmental impact and sustainable growth can be obtained. So, you have to think about that, whether this energy consumption will be economic or not, whether this energy whatever producing by other processes, whether it will give the positive impact in the environment or not. So, you have to consider that point, the positive impact on the environment for that process design. So, you have to design the process or develop the process in such a way that energy consumption will be less, even whatever energy will be produced, that should be produced in a way so that in your case that positive impact of the environment will be there. And also that the ultimate aim of the chemical process design is to synthesize a process that enables the production of desired chemicals in the most cost effective and that environmentally that is called benign manner and is flexible as well as easily operated. So, in that case you have to synthesis a product by a certain process design. In that case you have to that consider whether that product is coming with less hazardous materials or not, whatever byproducts, whether it should be easily separable or not, if it is separated how it should be consumed and where it can be reused, that should be also considered in that case. And for overall you have to calculate the how much cost actually factor will be there in that particular design. So, if you design that process by considering the size of the equipments, number of the equipments, even that synthesis of the chemicals, whatever solvents as a reactant should be used or any physical operations, what are the materials to be used, that should be considered there. So, that is why you have to design the process in such a way that should enable the production of desired chemicals in the most cost effective and the environmentally friendly, and also it should be flexible as well as easily operated. So, these are the main aim of the chemical process design. Now, for that process it should be sustainable, of course. So, to get the sustainable process design you have to that remember different aspects of that things. Sometimes you have to know that process improvement, there are several components for that, like sustainable process design, early stage design. You have to consider that whatever design earlier age they have used, so that should be considered, because from that onward you can improve also, otherwise newly process can be developed or designed there. So, based on the earlier process you can also design or you can intensify the process. Like that everybody knows that there is a two phase operations, gas liquid operations there, that development, or you can producing the bubbles in gas liquid system in a continuous liquid phase to separate the gaseous stream into a liquid stream. Now, later on whatever it can be intensified by producing the process or producing or developing the process in such a way that if you can reduce the size of the bubbles, you can get more interfacial area through which that mass transfer will be more. So, this is the one way to get the intensification of the process. So, in that case increasing the surface area, reducing the size of the bubbles, and also if you do it in a suppose certain process device, then in that case development of the process design also other way to that intensify the process. So, you have to consider the earlier stage, and from that you can intensify the process. Otherwise, to get the new process you have to consider other several factors like energy consumption, whether it should be eco friendly or not, whether it will be environmentally positive impact or not, that should be considered. So, in all these things should be considered for the sustainable design. So, you have to then consider that three components here: early stage design, after the sustainable process design to be considered, and then you have to consider that whatever it will be process improvement or not. So, all these things cyclic way you have to consider. Now, based on these three components you have to that consider the base reference design based on the existing that process. So, from which you can that analyze the problem where that earlier stage design is there, because of which you are getting less in yield. So, based on that you have to set target in such a way that you can intensify the process to get the more mass transfer, more heat transfer, more that you can say transport processes there, whether it is physical or chemical processes or not. So, based on this you can improve that process design, and based on which you can apply that things, you can get the reduce waste, even increase yield, and also improve environmental impact there. So, after that you can generate the alternatives that should be matched with the targets and methods for the process synthesis, design and intensification to be actually that accounted for that particular sustainable design. And after that if you are thinking that you are producing the process, or you can deriving the process for that particular synthesis and designing that equipment in such a way that for that particular process synthesis for that process intensification, you have to think another way, that is alternative way how to do this. For that you have to think about the new process, novel innovative way to do that, that synthesis. So parallelly you have to think about that. Not only that, intensify the process of existing process, you have to think parallelly what I can do for the new improvement of that process and new development of the process, or new way to actually synthesize the materials based on the available materials there. So that is why new novel and innovative process alternatives should be also considered for the sustainable development. And in that case, base case should be generated, and also methods for the process synthesis should be considered for that process alternatives. And ultimately your target should be the sustainable solution for that particular process, and also you have to evaluate whether it should be sustainable or not. So finally, at different levels you have to do this process design, and for the final recommendation you have to then analyze, or you have to assess the process whether it should be feasible for the sustainable development or not. Now what is that actually definition of that sustainable design? First of all, you have to know that what are the different components for that sustainable design to be considered. So based on that, the design of the process flow sheets, that should be considered, where it will correspond to a lower values of a set of targeted performance. That should be the criteria, and based on that criteria, economical, operational and environmental factors to be considered for that sustainable design. So that is why the sustainable design is to be defined as the design of a process flow sheets that correspond to lower values of a set of targeted performance criteria based on the economical, operational and environmental factors. So this is the definition for that sustainable design. Now what are the role for that process synthesis to give you the sustainable design? So in that case, whatever synthesis, process synthesis actually that you are considered, there should be a certain role for that. So in that case, role of that process synthesis to find the early stage design and the more sustainable design to generate the feasible process alternatives. And the generation of the alternatives can be done in various ways. For example, it is given like you have to consider the trial and error methods, rule based heuristics process, and process integration, generally for mass and that energy conservation that you have to consider for that process integration. And also process optimization, it is very important, whether this process whatever it is developed, that should be optimized based on the different operating variables, and the process integration should be considered based on that operating variables, whether that variables can be reduced for that process integration based on the concept of that for mass and energy conservation criteria. So and also other many factors you have to consider, like your policy, like your that materials available, whether that material should be that green materials or not, whether it should be hazardous or not, whether it should be the environmentally acceptable in range or not, that everything should be considered for that process synthesis. So the role of the process synthesis is to find out the early stage design and more sustainable design to generate the feasible process alternatives for the process intensification. And different ways are that here trial and error, rule based heuristics and process integration based on mass and energy balance, process optimization and more. Now how to improve that process design, and it is related to different criteria, different materials, even that operating variables, even other renewable resources that will impact on that improvement of the process design. So process design that related to the materials like catalyst, solvents. Catalyst means the screening and the selection of the novel catalyst for the reactive system to be considered there. That you have to synthesize the novel catalyst for a particular reaction. So that is why the catalyst, whatever it is synthesized, whether it is the environmentally giving the positive impact or not. So for that you have to consider, and based on that you have to improve the process design. Solvents, whatever it is being actually used for that process design, whether these solvents will be environmentally friendly solvents or not, and also that solvent whatever it is to be used, simply like that for extraction process, after extraction of that organic compounds, that should be separated. Now these solvents whether it should be easily separated or not. So based on that separation criteria you have to develop that solvents, or you have to use the solvent for the particular process, and accordingly your process should be designed. And other like materials, the design of the new materials to be considered here, and whether it should be novel or innovative, and whether it should be giving the novel innovative unit operations based on that materials or not, and whenever you will use that materials, that whether that should be giving the combined reaction and also separation and reaction separation systems altogether or not. Similarly, energy also to be considered, the use of the process integration concepts to generate more sustainable process alternatives with respect to reduced waste and environmental impact. So you have to design the process in such a way that where less energy will be consumed, and that energy whatever it is produced, that can be from the waste material or some other systems in the process integration system. What is that process integration? Sometimes whatever heat will be wasted, that heat should be reused for other processes. So that is why process integration will give you the intensification of the process where less energy can be consumed by utilizing the wastage energy in a particular process. So energy is one important criteria which will impact or which will affect on the sustainable process design. Now other thing is that scale based design. If the processes are designed at scales lower than the unit operation scale, there is an increased chance of finding or more sustainable overall process design. So in this case, sometimes you will see for the chemical engineering process like reaction engineering, nowadays some process equipment are being designed in such a way that its scale should be very lower in size, like you know that micro reactors, micro channel reactors, micro heat exchanger, even you know that micro chip heat exchanger, you know micro channel based heat exchangers. So those you know that devices are being used nowadays, where that scale is the main important factor. You are just designing the process equipment in such way that you are just reducing the size of the equipment, reducing the size of the you know provision or mechanical devices what is being used there. So in that case for that particular unit operation, that scale, in that particular scale the unit operation should be intensified. That means process, chemical process in the reaction, suppose the fast reactions, the channel based, where you can get the more interfacial area. So in that case the scale should be reduced, like I told that yeah, the micro bubble or nano bubble to be produced to get the more interfacial area, which is being used in you know that wastewater treatment, which is being used for you know that material processing, which is being used nowadays for medical science, like you know that for you know ultrasonography systems, they are using these micro bubble systems. That is a scale, you know micron size bubbles are being used. Even gene therapy, even you know that drug delivery, that micro bubbles are being used for that. So you are designing the system in such a way that either your fluid systems or fluid particles are actually reducing its size, or your equipment that is being reduced for that particular chemical engineering process or not. So if the processes are designed at scales lower than the unit operation scales, there is an increased chance of finding a more sustainable overall process. Like in that case you can get the more mass transfer, more heat transfer and other chemical engineering operation yield. Now process integration based design, in that case it can be considered as a special case of process intensification and is commonly defined as the design and analysis of the best or optimal network for mass and energy utilization that is applied to the design, or you can say that retrofitting and operation of new as well as existing processes. So you have to consider the process integration in such a way that your special case for that you know that design and analysis to be in such way that mass and energy utilization should be less, and it should be applied in such way that you are getting more yield by giving the less energy, and also it should be eco-friendly. Process integration is concerned with two integration concepts within a chemical processes. Any chemical engineering process, you will see whenever you are considering for intensification, you have to go through these two words like mass and energy. So, you can get the intensification of that chemical engineering process by conserving this mass and by that conserving the energy. Now, sometimes for conservation you have to use the less mass, or you have to intensify the mass transfer, like the transfer of the materials from one phase to another phase. There what will be the mass transfer? To get the intensification of that mass transfer, you have to increase the interfacial area of the phases through which that mass transfer will happen. Now, if you suppose do that, that absorption of the gaseous components to the liquid medium. So, you have to produce the surface area between the gas and liquid, through which that mass transfer will happen. Now, earlier stage you will see that there is a weighted column in chemical engineering process. In that case, through the center of the column gas is supplied, whereas adjacent to the wall the liquid will be falling down, or is being falling down as a thin liquid. So, in that case there will be contact between gas and liquid. So, through which there will be a mass transfer. Now, in that case it is seen that for that overall volume of that gas liquid mixture, the energy will be high, whereas you are getting the less contact area. Nowadays for the process intensification, this is being modified, like people are thinking different way to get the interfacial area between gas and liquid. So, for that what you have to do, or people are doing, they are designing the process in such way that if you can produce the bubbles of gas in a liquid medium, then you can get the interfacial area, so that you can get more that mass transfer between that surface. So, if you are producing bigger bubbles, you can get one interfacial area. If you break that bigger bubbles into finer bubbles, you can get more interfacial area than earlier. So, in that case intensification is going on just based on the increasing the interfacial area. Now, to increase that interfacial area, what is the actually energy is being used for that? Now, energy consumption or energy dissipation, that is coming, that air or gas to be supplied through the liquid medium by a compressor. Now, what will be the energies consumed by the compressor, that should be considered. So, that is why that energy consumption should be less in such way that whenever you are producing the gas bubbles, to get more interfacial area, you have to think for the design of that that process to produce that bubble in such way that you are using less energy. So, the concept of that process integration in that way that whatever energy is consumed for that producing that bubbles, and that bubbles will give you the mass transfer, and after that energy whatever it is dissipated, that energy may be used for other purposes. Now, what is to consider for that reuse of energy? Now, if we consider that suppose fluidized bed operation, in your case suppose simple example where suppose that coffee bean. Now, how to roast that coffee bean, green coffee bean to be roasted, after that it will be made as a what is that dust of that coffee bean, then you are getting the serve of your what is that coffee. Now, to make that brown coffee bean or roasted coffee bean, you have to use some fluidization process. Now, in that fluidization, that coffee bean to be fluidized in the air medium, hot air medium. Now, hot air is to be supplied through the compressor and through the heat exchanger, and after that coffee bean will be roasted. Now, this hot air, if you are not using further, that energy should be that wastage. Now, if you can use that wastage hot air for other purposes, then your integration of the process will be there, and you can utilize that wastage energy and you can intensify the process based on the less energy consumption. So, this is the way. So, you can use that hot air for other chemical engineering process where the liquid should be that heated up a certain temperature. So, that hot air energy, hot air, if you supplied for that through the heat exchanger, another heat exchanger for the heating of the that liquid medium for that reaction or other separation processes, in that case you can reuse this energy. So, one compressor and through the the heat exchanger, whatever heat is produced there and hot air whatever supplied, that you can use 2 or 3 processes there. So, that is why some other process like that, if your reaction is suppose exothermic reaction, so heat is that will be produced there based in that particular reaction. So, exothermic reaction, whatever heat is coming out, if you can use that heat for other that processes, then you will be benefited, or the process design should be in such a way that integration of that 2 processes will be done, so that you can get advantage of using that energy and getting the less energy consumption by integrating that process, and your process will be intensified. So, that is why the process integration is the concern with 2 integration concepts within a chemical or biochemical processes like mass and energy integration. What is that mass integration? For example, I have already told that minimization of the fresh water use in a process, like the efficient utilization of the mass within the process through the analysis and optimization of the mass flow within the process. So, you have to utilize of the mass within the process based on your less consumption of the mass, or suppose solvent you are using, how to use that less solvent or small amount of solvent to get the maximum separation of the other organic compounds. So, that is why the mass conservation, even mass utilization, mass optimization within the process to be considered for that particular mass integration process. Energy integration, like heat integration, whatever heat is coming out in a particular process, that can be reused for other processes. So, that is why analogy to that, mass energy integration is the efficient utilization of the energy within the process through the analysis and optimization of the energy that needs within the process. Example, that heat integration, already we have given that example for that, that fluidization, after that whatever heat is wasted, that heat should be reused for other chemical engineering processes. Now, what is the role of that chemist for process design? You will see that in that case, suppose a process is being designed by the chemist, where the reaction is be considered like A plus B, it will give you the product R. So, in that case you have to consider the reactant concentration. Now, if you are using the lower concentration of any suppose reactants, okay, now in that case to lowering the concentration you have to use more solvent, or you know that operating the semi batch process where feeding of any reactant like here B in slowly over many minutes of hours, that so that the system can cope with the heat release. So, if a chemical reaction that would necessarily take place in a few seconds and it will be slowed down to take 12 hours or more, it is clearly inefficient, it will be called. So, that is why the role of the chemist for the process design is very important for the consideration of the reactant, what type of solvents to be used, whether the concentration will be enough or not, whether it is the batch process or continuous process, what will be the mechanism of the feeding of the B, whether it will be slowly manner or the fast, that should be also considered, because that will give you the residence time of the reactants in the particular reactor, and residence time of the reactor will give you the process yield or reaction yield there. So, that is why the chemist always consider this reaction mechanism as well as the the concentration of the reactant to be used, and also how it will be supplied, whether it is semi batch or continuous way. There will be often other reactions like competing with the desired reactions. For example, A plus B will give you R, R plus B will give you S. Now, if the second reaction in this case is much slower than the first, there should be 2 mass S formed. and it should not be actually advisable, or it should not be considered, or it should not be desirable. So, however, if mixing is slow, in that case the first reaction can be artificially slowed down, which will then tend to favor production of S, that is here the final product, and yield will be reduced accordingly. So, in that case mixing is one important criteria. You have to slow down the mixing for that particular that final product of S to get more yield in that case. So, first reaction can be that easily slowed down, whereas for slow reaction what will happen, you cannot actually control that mixing phenomena. So, for slow reactions you have to intensify the mixing inside the reactor. So, in this case if you are increasing the mixing, so only the slow reaction, or you can say that where the physical separation is very slow, mass transfer will be very slow, or mass transfer coefficient will be very low. So, in that case you have to consider the first mixing for the slow reaction. Whereas for first reaction, in that case A will give you the directly here S, not intermediate products like R. So, for that case since you in this case the mixing is slow, the first reaction, that is A plus B is equal to R here, so can be artificially slowed down to give you the final product for S, and in that case your yield may be sometimes that reduce based on that that slowing of mixing. So, in that case you have to control the mixing characteristics inside the reactor to get the more residence time there. Now, in a plug flow reactor, reactants are brought together in the reaction zone and then removed, reducing the likelihood of the formation of S. So, if you are using stir tank reactants, you are getting that mixing characteristics, that is that arbitrary directions of the fluid element, that whatever substrate you are using or reactants you are using. So, in that case back mixing may happen. So, due to that back mixing there will be yield of reactions will be low, whereas in the plug flow there will be no chance of that back mixing of the reactant. So, it is called plug flow phenomena. So, in the plug flow reactors, reactants are that coming to each other, and in a particular zone there will be a reaction, and you can reduce the that final product of S based on that plug flow phenomena. So, to summarize, production of R will be optimized by ensuring that mixing, whether it is fast or desired reaction step, and that the reactor operates in a plug flow phenomena. So, in that case process intensification may get based on this plug flow phenomena. Because of this plug flow phenomena will give you the better yield. Nowadays that micro channel based reactors are coming. So, for that micro channel based reactors are nowadays that recommending for the fast reactions to get the better yield. Now, what will be the sustainable process design for a particular reaction? Now, if a reaction to be done in a reactor where you can assess the productivity, you can assess the selectivity based on the energy supplied. Now, you have to optimize that reaction yield or product based on that energy and also other that operating variables. Now, what are the upstream and what will be the operating conditions, what will be the downstream, what will be the separation or waste management, treatment, or all the process to be considered there. So, in that case what will be the raw materials to be used, what will be the cost of that raw materials, that also to be considered, whether it should be safety inventory or not, and also whether it should be mixing sensitive or not, whether it should be properly blending or not, whether mass transfer is happened properly or not, whether heat transfer is happened properly or not, how can you improve the yield that based on that mixing quality, and also that capacity of the design, that also to be considered there. So, for the overall reactions to get the sustainable process design, you have to consider that upstream along with that operating conditions, and downstream, and also you have to consider that separation mechanism, and also how to that manage that wastage material by that that output of that reaction. And in the reactor you have to model, you have to optimize the process or productivity based on that operating conditions, and also raw materials whatever will be used, what will be the price you have to consider for that. So, for the sustainable process of design, this outline of the reactor with the optimization and model analysis to be considered. So, safety value also to be parallelly considered for the process design for especially for this reaction system. Now, what are the design philosophy in that case? Now, if you consider that hydrodynamics of the plant, and if you consider based on that hydrodynamics how to design the chemical or that physical processes, how to design. So, all physical operations or you can say chemical operations in the chemical engineering process, you will see everything that depends on the hydrodynamics. So, you have to know the hydrodynamics first. Any reactor, whatever suppose fluid is used in a reactor, suppose there is a chemical engineering that is reaction is going on. Now, reactions to occur this reaction or to perform these reactions, what you have to do? You have to supply some reactant through some that inlet, and there will be outlet. So, there inside the reactor there will be a movement of the fluid. Now, you have to know the flow pattern of that movement of the fluid, whether it is the back mixing, whether it is plug flow phenomena, or whether it is ideal reactor, or whether it is non-ideal reactor, or what extent of non-ideality will be there, that can be assessed by the mixing characteristics, like that one the parameter in the mixing parameter, what is the intensity of the mixing, that you can assess by the residence time distribution, like axial dispersion model to be fit there, and there that Peclet number that to be considered there. 1 by Peclet number generally it is defined for the dispersion number. Now, if you have the more dispersion number, you can say that there will be more mixing inside that. So, based on that dispersion number, you have to assess whether this degree of mixing is enough or not. It will give you that ideal or non-ideality of that reactor. So, the flow pattern, that fluid mixer, how it will be mixed, and also fluid element, if it is suppose that particles are being used, what will be the that flow pattern of that particles, what will be the the distribution of the particles inside the reactor, that should be considered. So, all these things are considered as a hydrodynamics. So, based on that hydrodynamics, your reaction yield, process yield to be considered or assessed. So, based on that hydrodynamics, you have to design the reactor, and where you can get the reaction yield based on that design. So, you have to think the design of that process in intensified way, so that you can get more uniform distribution of the solid particles, more finer particles will be used there, you can produce more particles, soft particles of that phases, and also contact between the phases can be increased by that that mixing phenomena or other way, and distribution of the heat also to be considered. So, you have to consider all these heat transfer phenomena, mass transfer phenomena, like design aspect, heat transfer coefficient, mass transfer coefficient, all those parameters should be considered for the design of this that process. So, that is why hydrodynamics is the one of the important factor where this to be considered for the process intensification for sustainable design. So, that is why the design aim is to mixing rate to reaction rate to be considered, heat transfer performance to heat generation, residence time distribution. Of course, that mixing phenomena will give you the residence time distribution, how long that fluid particles will be residing inside the reactor. For the fast reactions, it may be that low, but for the physical operations where more residence time is required, in that case that residence time to be considered based on that mixing phenomena and other design. Sometimes you have to use some provisions in a reactor, so that that back mixing will be less. So, that is why in that direction you have to design the process. Now, flow pattern to reaction scheme, that is very important. That for ideal reactor, for non-ideal reactor, flow pattern is the very important. If you are getting the plug flow, there are different types of flow patterns, slug flow, plug flow, even that bubbly flow, even that pneumatic flow, even sometimes you will get that mist flow, spray flow. So, all those things are different types of flow patterns, that different flow patterns will give you the different consumption of energy, based on which you can get the reaction yield or process yield based on that flow pattern. So, you have to consider this flow pattern. So, flow pattern, residence time distribution, heat transfer phenomena, mass transfer phenomena, all those things are coming as a hydrodynamics part. So, you have to consider all these hydrodynamics part for your process design. Factors for optimal functioning. Now, optimal functioning of the reactive process that you have to consider for that reactor design, that will depend on careful process design with appropriately selected column internals, feed locations and catalyst placement. Very interesting that whenever you are designing any reactor, that you have to consider that process design in such way that if any internals are required or not, because your process intensification will be based on mixing of that reactants. Now, if you are using any internals for the mixings, to get the more degree of mixing, you have to use some that baffles or some other provisions, so that the liquid will go through the path where get more obstructions, and also fluid particles will be getting more that agitated, and so that you can get more mix of that fluid phase there. So, that is why you have to select the appropriate internals for that. Even sometimes that for heat transfer also, to get the more uniform heat transfer, you have to design the system in such a way that whether it is the channel based heat exchanger or some other way, to get the more heat transfer phenomena. Also feed locations in a certain that suppose distillation column, extractive distillation. So, in that case extraction as well as distillation both will be happening. So, in a particular where that feed location should be designed, you have to give proper design of that feed location, based on which you will see that performance of the process will be changing. So, feed locations are important factor where you have to consider. Catalyst placement also, you have to supply the catalyst either in continuous way or batch wise way. Now, catalyst you have to place in a particular, whether it is in the distributor location or in the top location, that you have to decide, and based on which you have to design your process equipment. So, greater understanding of the general and particular feature of the process behavior is required to know for that particular optimal functioning process design. Now, in that case, a point to be noted that plant performance is poor if the mixing rate is much lower than the natural speed of the desired reaction. Also, as plant performance improves with the mixing rate, that will be increased. So, does process performance improves up to the point where it becomes chemistry related. So, in that case you have to consider the mixing rate, whether it is lower or faster, whether it is the natural way of getting that speed of desired reaction or not, and you can improve that performance of the plant by this mixing rate. If you increase the mixing rate, performance may improve, sometimes may also that may not be improved, because that some mixing it will give you the less yield. So, in a particular cases that is case wise, that mixing will improve the performance of the plant. So, all these things actually depends on the chemistry, what are the different solvents, what type of that reactions will be going on, whether it will take more residence time or not. So, based on that chemistry part, so all this that plant performance will be depending on. Now, optimal design, that for that particular design of that process plant, that plant performance will be depending on that plant size, that plant policy, improved hydrodynamics phenomena that I have already discussed, even what is the chemistry behind that, what are the different that greener chemistry, or that greener chemicals will be used, materials to be used, solvents should be used, catalyst should be used, that should be considered, and also that improved chemistry, like you have to synthesize the materials in such a way that less hazardous materials should be reduced. So, that is why plant performance and process performance both are interrelated. In that case, process performance will be directly related to that plant performance based on this hydrodynamics and plant policy, chemistry and other operating variables. So, that is why the plant is to be designed to operate at a point at the top of the S curve here, as shown in here figure, as because here at this improved chemistry where the S curve will be flattens. So, in that particular location you have to consider to get the optimal design. Now, for that conceptual process design, you have to consider that process integrations, and which will be dealing with the systematic development of the process flow sheets, process synthesis activity, and also the automatic generation of the design alternatives and the selection of the better that ones based on the incomplete information also. Also, that conceptual design technology is required to help the engineer to find out the novel and improved solution to process design problems in a sustainable way in the context of the incomplete information whatever is coming from the earlier stage and also available resources. The synergy is conceptual process design that will use the elements of the heuristic, mathematics and the creativity of that. So, all these things should be considered whenever you are going to design a particular sustainable process. Now, basic points of process design strategy. What are the strategies for that? The components for that conventional design should be considered here for that strategy, that as per strategy. In that case, process flow sheet should be considered. Now, what are the existing process flow sheet and the technology that should be that considered for the analyze of that intensification way of process design, and you have to collect all those things process information, and you have to make the process flow sheet based on that know-how of that information of that existing flow sheet, and then you have to decompose that flow sheet into a functional sections, and also whenever you are going to that sectionalize that functional task, that you have to consider that equipment size and also particular process know-how of that operations. A black box approach as the that end point of the analysis, that also to be that considered, and this is the main strategy for this process design. In that case, raw materials, products, overall process relevant data should be that considered for your design. Otherwise, you will not get the, you will not be able to assess the optimal design if you do not know that raw materials, the cost of that raw materials, and also products, what are the products and what will be the separation criteria, what will be the different physical properties or the process yield what is coming, that should be considered, and also overall process relevant data also. Sometimes that mass transfer coefficient, heat transfer coefficient, reaction kinetics, all those things to be considered. So, this is the strategy that to find out the process design, optimal process design for the sustainable development. Now, next what you have to do, that after getting this process relevant data for that black box formation, you have to formulate the goals for the new design, and the black box is the start of the rebuilding of the process, that from the outside to inside. So, that is why all this process design data to be considered to formulate the new design, and after that systematic process rebuilding, and that including known and creative technologies, and also what will be the breakthroughs and process simulations that should be considered for your that systematic way of process design. Now, simulation is very important. Whenever you are designing that process, what will be the outcome is expected, that you can predict based on your model development. After the simulation means what is that, based on that model you can expect that what will be the trend of that output after design, that you have to consider, or that is the strategy here to that consider the model, and what will be the prediction trend of that particular process output will come based on this simulation. And then application of the management tools in the form of tree diagram in terms of goals. Of course, that whatever goals you are expecting based on this simulation, then you have to target that goal. Suppose within a certain time period you expect this that output, this amount of output is required based on the operating conditions, based on this the process relevant data, based on your equipment design. Now, if you are targeting the goal of this output based on this simulation data, then you have to fix the management tools in the form of tree diagrams, so that for this particular operating conditions you can get this output. For this particular step you can consider these things. For this control of this input you can get this output. So, this type of things should be considered. So, that is why proper management is required. So, that management tree should be formed, and it is being formed for this that process design as a basic consideration. Now, step by step design strategies to be considered, like that systematic process design cannot be done in one step. There are several steps to be considered here. In that case, if you consider that a task of process where you conversion of raw materials, suppose A and B into product C, and to minimize byproduct or waste, it is denoted by D. So, in that case the states of materials, you have to know that whether this A, B, C and D are defined as mass flow, composition, phase, form or temperature or pressure, that you have to consider these that variables. Now, this process design has to consider that alternatives for raw materials and process routes that lead to a given product. So, for this you have to consider the step by step design strategy. As a first step, what you have to do, that you have to eliminate the differences in the molecular type by chemical reaction. Now, what will be the reactant and what type of reactant should be used, what type of catalyst should be used, what will be the solvent, what will be the characteristics of the solvent, if you are using catalyst, what will be the size of the catalyst, what will be the distribution of the catalyst particles, everything should be considered. And in that case, some variables should be interacting to each other. Maybe that suppose physical properties, if you are using that slurry systems, if you are considering concentration, you need not to consider the viscosity. If you are not considering the viscosity, you need not to consider the concentration, because they are interrelated. So, that is why you have to eliminate the differences in the molecular type, like based on that physical properties, like in that case that viscosity or other physical properties there. And the function of the reactor as a second step should be considered. In that case, the heart of the chemical process, in that case that what type of function, whether these raw materials are converted into the desired products and at the required impurities, that how it will be that related to the other operating conditions. Now, maybe that yield is directly proportional to the that reactor conditions, or you can say that the output of this or reactor performance or process performance is directly related to the hydrodynamics. So, you have to make a function like that process yield, if you are considering that P process yield or Y, that is a function of what is that different variables, or it may be suppose physical operations, the that efficiency of the absorption process. Now, that efficiency of the absorption process depends on mass transfer, that depends on mass transfer coefficient, that will be assessed. Now, this mass transfer coefficient depends on what? This depends on flow rate of the fluid, that geometry of the system, like the size of the reactor, length, diameter, even the distributor size of that that phases, and also it may be that temperature dependent, it may be pressure dependent, it may be that physical properties as a variable that will affect on that performance. So, all these things to be considered. So, in that case the process efficiency is a function of that velocity of the fluid whatever supplied, the size of the catalyst, that size of the reactor, maybe diameter of the reactor, even know the physical properties of the system like the density of the fluid, that surface tension of the fluid, that viscosity of the fluid, and also you can say that some other mechanical provisions like that internal length or some other things. So, all these things to be considered. So, that is why you have to make a function based on your operating variables. Now, step 3, that you have to connect between process units, and in that case from raw materials to the reactor, purification and conditioning of the feeds to be considered there, whether it should be that heat sensitive or pressure sensitive that you have to consider. From separator to product, final purification that you have to consider based on your operating variables. Reactor separator connections, in that case process integration is coming, and in that case how you are combining these two reactor and separator to get your that process design. In that case you can reduce the temperature and the pressure. Connections of the separator outlets, reactor performance, process components, recovery and recycles from separators, connectors to other that system like reactor system or extractive system or other things. So, in that case as a third step you have to consider the connections between the process units. As a step 4, what you have to do that you have to measure the mass flow, including that excess of one component that is required in the reactor. Suppose in a particular reactions excess amount of reactants to be required. So, you have to consider all those factor also. So, in that case activity and also building preliminary mass balances to be considered before other conservation laws you are assessing. So, the output of the step 4 is an overview of the process functions that will be needed to realize the transition of raw materials into products, including alternative flow sheets and unit operations that could be of course considered. And next step is that the combination of unit operations or task integration to develop the opportunities for process integration, like leading to smaller, more efficient and that cheaper processes. So, this step includes screening for the options related to the heat integration, or you can say that reactive separations, or other that if you are using the like extractive distillation or that absorptive distillation, all those things to be considered there as an integrated system. And final step is that it consists of the setup of the mass and heat balances, and then based on that heat and mass balances, and you have to that make a functions of that process yield, whether it is that separation or reactions, or that combination of that reaction or separation or not. Out of various process alternatives, the most promising ones need to be selected by considering the profit, process yield, controllability, safety and ecological aspects. So, between the steps interactions will take place there, and decisions can be considered where the need for loops to the previous steps is required, and in that case as an example you can say that the consideration of the reactions for the step 1 and the separation as a step 2 to be known in detail. So, I think we have discussed here in this lecture that different strategies of the that process intensification for the sustainable development. So, I think you can get more information from this further reading of these books. So, thank you for giving attention for this lecture. So, thank you for